Hello everybody, this is Srija Gautam, and in this video we are going to discuss about Amazon QLDB or Amazon Quantum Ledger Database. So let's jump in and get started. So QLDB is the newest launch by Amazon Web Services in November 2018 and it is still in preview. QLDB provides us with some of the common characteristics of blockchain technology. It has provided us with a better or improvised version of record keeping. It is fully owned and managed by Amazon Web Services. So, which brings us what is Amazon QLDB. So, Amazon QLDB is a ledger database. And what is a ledger? So, ledger can be understood as a collection of sequence data. So, for example, the financial accounts, the registry log that we used earlier. Next, it is a customized or it is a purpose built database which can be customized as per the organization needs. It has an amazing cryptographical ability which makes sure that the data in the database is accurate and it is not modified. It provides a user friendly SQL interface to build applications. Let's talk about the characteristics of QLDB. So first we have immutability. So immutability can be understood that it has a complete sequence of events that occurred on any transaction or any data record, and which can be revisited and can be analyzed that it is correct or it was never been modified or updated. Next we have cryptographical verification. So for this we have an amazing function, SHA-256 function, which provides a unique hash value every time a transaction is run in QLDB. Next we have scalability. So since Amazon S3 is an amazing cloud storage, so QLDB is supported by S3 and it scales automatically as per the user demands. And next we have easy to manage. So since it is a centralized system, it is very easy to manage, user friendly. QLDB is a document oriented model, which means that we don't have to worry about the attributes of the table or the functions. We just have to know the tables and our job is done, which is very similar to the SQL APIs. Next we have Amazon architecture or Amazon QLDB architecture. Let's see that way. So here we have an application data coming from a particular application into the quantum ledger database. So this database has two components. One is journal and the other one is current and history index. So what journal has is a space where each and every transaction runs and the logs that we can see between those transactions. So they are the unique hash value generated by SHA-256. And then the data processed from that journal is being uploaded or is being stored in current and history indexes. So current would have the latest data, whereas the history would have the oldest, or we can say all of the data of the user. We can go back in future, we can go back from the future and verify that the data is correct, since we have the cryptographical functionality with us. And we can access the entire history of our data records whenever needed. So this is the architecture. Now we talk about how it actually works. So here I have written some queries where a customer comes to a bank. He did some transactions and let's see how it looks on the table. So here in the first transaction, what happened? So the customer came and his records are getting inserted in the bank's database with the account ID, name, account type and total amount of $1,000. On the same time, the history table was also updated, and this first transaction created a unique hash value by SHA-256 as H1. So when after some time what a customer did, he withdraws all the amount, and then the table would look like, so the current table would have 0, the latest data, whereas the history table would have both the records, so the latest one on the top and the oldest one in the bottom. And this transaction also creates a specific or a unique hash function, like h2. So h2 would have some properties of h1, and thus links both transaction 1 and transaction 2 together. Now let's say after some time the customer wants to terminate his account, so he did that, and the current table would look like that, because there is no record, it will look like this. Whereas in the history table we'll get three records, so we'll get the latest one where we do not have account of the customer, then 0, and then from the initial, so the latest one on the top and then the oldest one at the bottom of the table. This also produces a hash function which is unique and which will be connected with h2, and we can say that all the three hashes are connected directly or indirectly with each other, and which provides a cryptographical verification ability to the users to verify the data whenever they need if something goes wrong. So that's bring us to here. So where can we implement Amazon QLDB? So we talked about centralized data, we talked about verifiable history data, we talked about access of data over time. So I would say that I have few examples here with the HR and payroll, manufacturing and supply chain, banking and finance, and healthcare obviously. So since it has a very critical data of patient, so it would be beneficial if we have all the records of the patient and the treatment would be done accordingly. So I think this brings me with the completion of this presentation, and I hope you guys liked this video. And if you have some questions, please post them in the comment section below, and thank you very much.